Hi children, yesterday we discussed what is the prism and definitions of the terms which are related to prism, means what is the angle of incidence, what is the angle of emergence, what is the angle of deviation. These are all definitions we have learnt yesterday. And third one is find the refractive index of material of prism. This is how to find the refractive index of the material of the prism. Yesterday we discussed through one lab activity that I presented through video. Fourth one is derivation of refractive index of prism. What is the derivation of refractive index of prism means how to derive. Yesterday I derived this refractive index of the prism. Then the refractive index of the prism is n equal to sin a plus d by 2 by sin of a by 2. This is the refractive index of the prism. And last one is how to solve the problems on refractive index of the prism. Here they will give in that problem the values of a and d and a. How can you find the refractive index of the prism? Yesterday we discussed these all things. Now the next topic is least distance of distinct vision. For our understanding, we have an activity in your textbook. Take one textbook, hold your textbook with your hand, and try to the context which are given, which are printed in your textbook. Now try to bring the textbook very close to your eye. Then are you able to see the text which are printed in textbook? So if you are not able to see the text which is printed on your textbook, now the textbook, you have to make the textbook to move away from your eye. At what distance you are able to see the text, you are able to see the context which are printed on your textbook. That is comfort to you. The distance from your eye to object is called least distance of distinct vision of your eye. So the least distance of distinct vision of healthy person is 25 centimeters. So here the least distance of distinct vision is vary from person to person. When the age below 10 years, the least distance of distinct vision is 7 to 8 centimeters because of muscles around the eye strong and flexible. The muscles which are present in which are around the eye, those are strong and flexible. Next, what about old people? What about old people? The least distance of distinct vision of old people is about 1 to 2 meters because of the muscles cannot sustain more strain. That's why the least distance of distinct vision varies from person to person. The next topic is angle of vision. Here, for what is the angle of vision? For our understanding, we have an activity. I will show that activity through one video. Before going to see that video, I am explaining what is the angle of vision. So here I am taking an object, AB object. AB object. Here, when the AB object move away from your eye, then we are able to see the whole object of the whole object. When the object is at AB, then you can see the object. The object moves towards your eye, then the rays which are coming from extend point, the rays which are coming from least means ending points, that is A and B, the rays reaches your eye, then only we are able to see the whole object. But here, when object is moves towards your eye, then the rays which are coming from A dash and B dash, those are not reaches your eye. That's why you are not able to see the whole object. So we can see only a small part of the object, some portion of the object. So here when we measure the angle, that angle should be 60 degrees, less than 60 degrees. When the angle is below 60 degrees, we can see whole object. More than 60 degrees, we can see some part of the object. What is the angle of vision? The maximum angle at which we are able to see the whole object is called angle of vision. So for our understanding this angle of vision, we have to do an activity. We have to do an activity through video.
Here, let us perform an activity to get an idea of clear vision. Arrange a retort stand. Collect some wooden sticks that are used for rolling the cloth in cloth store, or collect PVC pipes used for electric wiring. Gather sticks or pipes of different lengths, say 20 centimeters, 30 centimeters, 35 centimeters, 40 centimeters, and 50 centimeters. Place the retard stand on a table. Stand near the table in a way that your head and the vertical stand are side by side. Adjust and fix the clamp on horizontal rod such that the distance between your eye simultaneously without any change in the position of eye, either vertically or laterally. Assume that the whole object is AB. We can see that object which is at a distance of 25 centimeters, least distance of clear vision, because the rays coming from the ends A and B of the object AB will enter into the eye. In the same way, we can also see complete object CD 30 centimeter stick with eye as explained above. Make an assumption that AB is moving close to your eye to your position A. The complete object is called angle of vision. For a healthy human being, the angle of vision is about 60 degrees. It varies from person to person and with their age. We have learnt that the value of least distance of clear vision is about 25 centimeters and the value of angle of vision of human beings is about 60 degrees. These values change for different persons according to their age. Why? To answer the above question, we need to understand the structure of eye and its functioning.
Surfaces. This reflected light enters our eyes and we see that object. What happens inside the human eye when the light rays enter it? What is it that helps us see the things around us? The human eye is roughly spherical in shape. What we're going to do in this video is understand the different parts of the eye in short, not in extreme detail. Let's begin. The outer layer of the eye is called the cornea. It's white in color and transparent. Transparent? Yes, it means that it allows light to pass through it. In fact, cornea refracts or bends the light passing through it. And much of the refraction inside the eye is done by cornea. But wait, it not only refracts light but also protects the inner parts of the eye. It acts like a tough front wall of the eye, protecting the interior of the eye from accidents, and also does not allow foreign particles to enter. Okay, so this was all about the outer layer of the eye. Let's now talk about the things present inside. Behind the cornea, there's a dark muscular structure called the iris. Iris determines the color of the eye. For instance, when we say that a person has blue eyes, it means that the color of the iris of the person's eye is blue. Now there is a small opening at the center of the iris for the light to enter. Do you know what it's called? It's called the pupil. The iris actually acts like a shutter of a camera. It controls the amount of light entering the eye by enlarging or shrinking and thereby adjusting the size of the pupil. For example, when you focus the light from the torch directly into a person's eye, the iris shrinks. This is because the intensity of light is too much for the eyes to bear. The shrinking iris stops the unwanted light from entering through the pupil. And when there's less light, it expands, allowing more light to enter through the pupil. Okay, what happens next? The light that enters through the pupil falls on the lens kept behind. The lens is a convex lens. Convex lens is a lens which is thicker at the center than the edges. It's a converging lens. That is, it focuses all the light at one point. In a normal regular eye, this point is somewhere here on this inner boundary called retina. Why do I say a normal eye? Well, in a defective eye, this point of focus may lie either in front of the retina or behind the retina. We will talk about this defect of eye in our future videos, but first, let's go back to our normal eye where light is focused on the retina. Retina is at the back of the eye and marks the inner layer of the eyeball. Retina contains lots of nerve cells that sense the light. The nerve cells are of two kinds, namely cones, which are sensitive to bright light, and rods, which are sensitive to dim light. The message or sensation is then transferred to the brain along the optic nerve. Okay, let's quickly recap what we learned about the human eye. Human eye has a roughly spherical shape. The outer part of an eye, called the cornea, is a thick white transparent wall which protects the eye from accidents and keeps the foreign particles from entering inside. Behind the cornea, the colourful part of the eye, called the iris, is present. It has a small opening at the centre called pupil. Iris controls the light entering through the pupil by contracting and expanding. Behind the pupil, there is a converging lens which focuses the light on retina. Retina consists of two types of nerve cells, namely cones and rods. They transfer the message through the optic nerve. There is a lot of information to digest.
The next topic is structure of eye. This is a cross section of eye. Here, when we observe the cross section of eye, here, first one is this bulbous portion is said to be. This is the bulbous portion is said to be cornea. This total eyeball, and here this is called eye lens. This is called eye lens, and these eye lens are managed by the ciliary modules. Ciliary modules are change the focal length of eye lens, and this is the iris, and this one is pupil, and between the iris and cornea, one liquid is present, that is the aqueous humor. So what in this this structure of eye, I will, for understanding, I will show one video. So in this total topic, these are very important in the class. What is the working of pupil? What is the working of iris? What is the working of ciliary modules? What is the accommodation of eye? So what is a pupil? Pupil means it is a black in color. When a light enter into the eye through pupil, it is a black in color. What will happen? It makes the light cannot come back from our eye. The next one is the iris. Iris always control the pupil. Iris make the pupil in a low light condition, in bright light condition. In low light condition, iris make the pupil expand. Due to the expand of pupil, more light is allows go in your eye. When in bright light condition, iris make the pupil contract. Due to this contract, because of why the contract takes place here, by prevent the excess of light not to go in your eye. The next, what is the working of ciliary modules? Here, ciliary modules are present. What is the working of ciliary modules? Here, two conditions we are taking. One is when the object is a distant object, when the object is closer object. When the object is distant object, here the ciliary modules are in relaxed position. Then the focal length of eye lens is that is equal to the distance between lens to retina, that is 2.5 centimeters. And what is the when object is closer when object is closer to your eye, then automatically here the eye lens taking more strain, then automatically the focal length of eye lens ciliary modules taking more strain here, the focal length of eye lens decreases. Why? Because here contraction takes place, the eye lens contraction takes place. So automatically when eye lens contraction takes place, automatically focal length decreases. So that's why even though eye lens make a image on retina, So what is here what we observe? What is the working of ciliary muscles? Ciliary muscles, it is a process always one work doing in your eye. What is the working of ciliary muscles means? It is the always change the focal length of your eye lens. This is called accommodation of eye.
Power of accommodation. The human eye is able to see objects with the help of eye lens and retina. The eye lens is held by ciliary muscles. Normal human eye can see nearby and far objects clearly. Power of accommodation. The ability of the eye lens to increase or decrease its focal length to some extent by ciliary muscles is called power of accommodation. Working of eye lens. The eye lens is made of a fibrous jelly-like material and hence it is flexible. To see far-off objects clearly, the ciliary muscles relax to decrease curvature of the lens and it becomes thin and its focal length increases. Thus, image of far-off objects is made on retina and the eye is able to see distant objects. To see nearby objects, the ciliary muscles contract to increase curvature of the lens and it becomes thick. Thus, focal length of the eye decreases and it is able to see nearby objects distinctly like reading. Limitation of power of accommodation. The focal length of the eye cannot be decreased below a specific limit. The eye cannot see objects clearly below 25 centimeter. So near point of distinct vision for normal human eye is 25 centimeter. However, there is no such limit for distant objects. Therefore, far point of normal human eye.
Now, how to find maximum focal length of eye lens? Here we are observing two cases. One is the object is at infinity. Another one is object is at a least distance of distinct vision. So first I am taking an object is at infinity. You know that the rays which are coming from infinity object, they are parallel. So these parallel rays are enter to your eye, refraction from the lens, then reaches to your retina. So here image we will get on retina. So when the object is at infinity means the object distance, let me take that is infinity and B is 2.5 centimeter. Why? Because the distance between lens to retina is 2.5 centimeters. So that is 2.5 centimeters. These values is substitute in lens formula, that is 1 by f equal to 1 by v minus 1 by u. So 1 by v means 1 by 2.5 minus 1 by minus infinity. This term becomes plus. So 1 by 2.5 plus 1 by infinity. Already we know that 1 by infinity is nothing but that is 0. Then you will get 1 by f equal 1 by 2.5, then f equal to 2.5. So this is the maximum focal length. Now when the object is at infinity, case 2. When the object is at case 2, when the object is at a least distance of distinct vision. So the least distance of distinct vision of healthy person is 25 centimeters. So this is object distance, this is image distance. So object distance is 25 centimeters, image distance is 2.5 centimeters. We know that when we apply sign convention, here the distance measured from the lens is the distance measured from the lens. That is the first point. Second point is the rays which are coming from object is opposite to the object distance is opposite to the incident ray. That's why we are taking negative. So u equal to minus 25 centimeters, v equal to 2.5 centimeters, 1 by f equal to 1 by v minus 1 by u. This is the lens formula. Substitute these values in this formula. 1 by f equal to 1 by 2.5 minus of minus 1 by 25. Then we can write 1 by 2.5 means that is 10 by 25 plus 1 by 25, that equal to here denominators are equal, that's why we can add numerators, then that becomes 11 by 25. So here f equal to this fraction becomes reciprocal, that is 25 by 11, that equal to 2.27 centimeters. This is a f minimum. So minimum focal length of eye lens is 2.27 centimeters. Maximum focal length of eye lens is 2.5 centimeters. This focal length of eye lens varies between 2.5 to 2.27. Now the next topic is here. Already we discussed ciliary images are change the focal length of eye lens. That phenomenon is said to be accommodation of eye lens, accommodation of eye. Then already we discussed that is the maximum focal length of eye lens is 2.5 centimeters. Minimum focal length of eye lens is 2.27 centimeters. Here focal length varies. If the focal length cannot vary, what happens to our eye? Our eye getting defects. How many types of in your textbook, in your 10th class textbook, mainly we observe 3 common defects of vision. They are myopia, hypermetropia and presbyopia. I will explain these 3, myopia and hypermetropia and presbyopia and correction, through one video.
Let us learn more about the defects of eye lens. There are mainly 3 common defects of vision. They are myopia, hypermetropia, presbyopia. Click each tab to learn more. Myopia is an eye defect and is also known as nearsightedness. A person with myopia defect cannot see the distant objects but can see nearby objects clearly. These people have less than the maximum focal length of eye lens, that is 2.5 centimeters. In such cases, the light rays entering into eye from the distant objects converge through eye lens and form an image in front of the retina. In case of a healthy person, the eye can see objects at all distances more than 25 centimeters clearly. But in case of a person with myopia, eye can see objects clearly up to a certain distance. Let us consider a point M, where an object appears clearly to a person with myopia. If the object O is placed between M and point of least distance of clear vision L, the eye lens can form the image on retina. This point M is called far point. In other words, this point can be stated as the maximum distance point at which the eye lens can form an image on retina. The defect in which people cannot see objects beyond far point is called myopia. When an object is kept between a far point and the least distance point of clear vision, the eye lens can form clear image on retina. When the image of the object is brought in between the far point and the least distance of clear vision, it acts as an object for the eye lens. This is possible only when a concave lens is used. Here, a biconcave lens is used to correct the myopia defect, because this lens forms an image at the far point for an object at a distance of infinity. Let us find the focal length of this biconcave lens. In this case, object distance u is minus infinity and the distance of far point v is minus d. The focal length f of biconcave lens can be found by using lens formula. Lens formula is 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to 1 by minus d plus 1 by infinity. 1 by f is equal to 1 by minus d. F is equal to minus d. Here f is negative, which indicates that the lens is a concave lens. Hypermetropia is an eye defect and is also known as far-sightedness. A person with hypermetropia defect is able to see the distant objects clearly and distinctively, but cannot see nearby objects comfortably. For the person of hypermetropia, the focal length is more than 2.27 centimeters. In such cases, the light rays enters the eye and converges behind the retina. Consider a point of least distance h at which the eye lens form clear image on retina for a person with hypermetropia. The eye can form its image on retina when the object is placed at h or beyond h. If the object is placed between h and point of least distance of clear vision L, then it cannot form an image. The eye lens can form an image on retina at the point of minimum distance called near point h. A person with hypermetropia cannot see the objects placed between near point and point of least distance of clear vision. Here, a biconvex lens is used to correct the hypermetropia defect because this lens forms an image of the object beyond near point. The formation of this image acts like an object for eye lens. Hence, final image due to eye is formed at retina. Let us find the focal length of this biconvex lens. In this case, object distance u is minus 25 centimeters and distance of near point v is minus d. The focal length f of biconvex lens can be found by using lens formula. Lens formula is 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to 1 by minus d minus 1 by minus 25. 1 by f is equal to minus 1 by d plus 1 by 25. 1 by f is equal to d minus 25 by 25d. F is equal to 25d by d minus 25. We know that if d greater than 25 centimeters, then f becomes positive. So, biconvex lens is used to correct the defect of hypermetropia. Presbyopia is a natural part of the aging process of the eye. So, it cannot be treated as a disease. It is a common defect of vision, which generally happens at old age. After 45 years of age, the power of accommodation of the eye normally decreases. After this age, most of the people, the near point slowly recedes away. As a result of loss of elasticity in the lens of the eye, vision of far objects remain unchanged, but accommodation of the eye to near objects is reduced. This happens due to gradual weakening of ciliary muscles and diminishing flexibility of the eye lens. Sometimes a person may suffer from both myopia and hypermetropia with aging. In such cases, bifocal lenses are required to correct this type of defect of vision. Bifocal lens consists of both concave and convex lenses. Its lower position consists of a convex lens and upper position consists of a concave lens.
Today we discussed the first one is least distance of distinct vision. Least distance of distinct vision. Least distance of distinct vision. Second one is angle of vision. Angle of vision. And third one is structure of eye. Structure of eye. In the structure of eye, we discussed what is the working of iris, what is the working of pupil, what is the working of ciliary muscles, what is the accommodation of eye. These definitions are very important in this topic. And fourth one is how to find the maximum focal length of eye lens and the minimum focal length of eye lens. What is the maximum focal length of eye lens? Already we got, that is 2.5 centimeters. Minimum focal length of eye lens, that is equal to 2.27 centimeters. 2.27 centimeters.